Welcome back. We are talking about the different options under water and wastewater engineering. In this video, we'll be talking about different sludge handling operations. There are a number of operations to handle the sludge, which is generated in the primary or secondary segmentation tanks. To understand the sludge handling, first of all, we should see what the sludge contains. Sludge contains water and solids. So if water is reduced, solids will improve. Very simple. So more water means more weight, more volume, and more difficult to handle. So what are the options we are trying to identify that should reduce the moisture content, increase the solids content? So these methods are mainly based on some simple physical, chemical, or biological methods. The sludge is finally disposed of after reduction of its moisture content. So if you see the sequence of activities, the wastewater treatment is completed, the sludge is generated. So now we have different options before it is finally disposed of. What are the different options? Concentration or thickening, digestioning, and then conditioning, dewatering, heat drying, and incineration, under which we are having a number of options: gravity thickener, centrifugation, flotation, anaerobic, aerobic digestion. And we'll try to see some of the major important operations which are usually adopted in the sludge handling operations. And the last column gives the different mechanisms, the principle. The gravity thickener is based on gravity settling. Similarly, anaerobic digestion is based on anaerobic decomposition. Sludge drying beds are mainly dependent upon dewatering and filtering techniques, and incineration based on heating at high temperature to reduce or evaporate the water in the sludge, to name a few. Now let us look at the first one, conditioning. We talk about conditioning. What is the meaning of conditioning? It improves the drainability of the digested sludge. The first option we consider here is illustration. Illustration is nothing but the process of washing the sludge water to remove organic and fatty acids which are deposited. They are deposited during anaerobic digestion process. If they are not removed, they will interfere with the vacuum filtration. How to remove these solids? The sludge and water are mixed in a container for around 20 seconds. The sludge is then settled out in the settling tanks and excess water is decanted. Co-current or counter-current operations are practiced. Co-current means water and sludge same direction. Counter-current means water and sludge in opposite directions. So now you see another option here, the thickening. Thickening means settling of sludge solids in a tank similar to the sedimentation tank. The underflow contains coarse and thickened solids. The gravity thickener, if you see here, in place of water, raw water or sewage, we will put the sludge in the gravity thickener. So ultimately what will happen, there are again solids, coarser solids and finer solids. Coarser solids will settle to the bottom and finer solids will be under suspension. So thereby the concentration of solids will reduce. Ultimately, what is the objective? Solids content should reduce. And water is separated out. Solids and water are separated out. So water will go away. Ultimately, what we are having, the solids there at the bottom. So water is removed, solids are only there, the weight is reduced. The flotation thickener, this is similar to that of gravity thickener, but here gravity thickener we are using only gravity. We are not using any external mechanism. Here we are sending a compressed air from the bottom so that particles and water are separated. Particles will be pushed to the top and water is separated out. So that's how the water and the solids are separated out. Thickened sludge is separated from the top and the water is taken from the bottom. Dewatering. Dewatering means reduction of moisture from the sludge. Now here we will adopt two major operations. Pressure filter. So now the pressure filter, what you see, there are a number of bags like this. There's a series of bags are there. So you send the sludge inside, and then in between the bags, you're sending the sludge, and then we'll try to compress like this. The compress, you are pressurizing. When you compress the sludge, then water squeezes out, and sludge particles will get attached to the inner surfaces of the uh, bags, and that will be separated out. The vacuum filter uses a suction or vacuum to filter out water from the solids or a porous surface. Now what you're having a cylinder, a rotating drum is there. It is immersed in a tank which is having a sludge inside it, is rotated. On top you are having a filter cloth. This is having a large number of pores. Inside is a hollow. Now when the drum is rotating, and then it is suction is applied to the drum. When the drum is moving and suction is applied, then ultimately what will happen? It will push the water from the sludge through the pores, because solids cannot pass through the pores, only solid water can pass through. So water can be pushed through the inner surface, and the solids will get separated out and then will stick to the outer surface of the vacuum filter. So solids are scraped out. You can see here the scraping surface is provided to separate the solids, and water is taken out separately from the drum. Dewatering, reduction of moisture from the sludge. How you are going to do that? Sludge drying bed is one option. What you are doing, you are spreading the sludge on a sand bed. Sand bed is provided with a gravel for support. So ultimately what will happen, the water will pass through the grains of the or voids of the sand, and then the liquid will get filtered through and then collected to the bottom. So, dry particles will get separated at the top. So it will be left open to the atmosphere for drying of the sand, drying of the sludge. So after the drying, but 1 to 2 weeks, the sludge will form as a cake, dry cake. That dry cake will be scraped out and removed. Whatever the water comes out, separated out and collected as a filtrate is now collected separately and sent back into the treatment operation. So it's a simple dewatering or filtering technique. Centrifuge is a fast rotation cylindrical bowl to separate the wastewater liquid from the solids. It removes more water than other methods and leaves solid material that is known as a cake. Mainly centrifugal force is the separation. The another option which is used for sludge handling is the digestion. Digestion is the process of reducing volume of sludge through anaerobic decomposition or aerobic decomposition. A digester is the tank which we are using for digestion. If it is anaerobic process, is called as anaerobic digester. If it is aerobic, is called as aerobic digester. The volatile solids are reduced in this digestion process, and they are partially converted into biogas, and the water and solids are separated out. Digested sludge is there at the bottom, and then liquid is there in the middle, gas is there at the top, and the active sludge is there somewhere in the middle, somewhere close to the bottom. So this digester which is used for anaerobic digestion is called as anaerobic digester, also called as a sludge digester. Biogas plant which is based on this anaerobic digestion principle. It is used to generate gas from cow dung or any other agricultural waste material or food waste materials. Drying is simply reduction of moisture from sludge by applying heat. Then we are having a rotary dryer. Now you can see here rotary dryer. Sludge is passed into a rotary drum where the heat is supplied. So this is rotating and then heat is supplied here. So ultimately what will happen is while the sludge is passing through the drum, it gets dried up, and then the sludge's solids are separated out. Okay, that is the main thing of the sludge rotary dryer. It all depends on how much is the residence time required to move the sludge from the one end inlet to the outlet. Flash dryer is sludge along with the heat is sent into a dryer. Water and waste gases due to sludge drying are escaped. So now you can see here water in sludge along with the heat both are sent into a dryer here, and water and waste gases due to sludge drying escape, leaving dry sludge for collection. So dry sludge is there for collection, and now hot air is sent here, and the sludge is along with that you are sending here, and then heating it in the flash dryer. And the common option which is used is incineration. Incineration is nothing but destruction of volatile solids at high temperature at 650 to 750 centigrade with auxiliary fuels. The other dryers which we just now discussed is only giving just small temperatures, is just enough to convert the water into a vapor. Now here the volatile solids are also there. They will be evaporated only at a temperatures more than 550 centigrade. So in this incineration process, when we are heating these solids to more than 550 centigrade, all the volatile solids will get escaped, and only inorganic solids or inert solids are there. Inert solids will not take part in any decomposition process. The problem comes only with the organic solids or volatile solids. So that's why we are using a incineration process. Two different options are there. One is multiple hearth furnace. So what you are seeing is the number of steps are there here, number of stages or number of platforms. These are called multiple hearth. So when the sludge is allowed here, it falls from one top to the bottom, next layer, next level, next level, next level, so that residence time is increased. In between the bottom here, the platform, you're having a number of holes. So the heat will be coming from the bottom. The heat will heat up the water in the sludge. It will get dried up by the time it reaches to the bottom. The fluidized bed furnace, what you are seeing is now the entire sludge is kept under fluidized state in the floating stage, so that the sludge and water they'll try to get separated out in this process. That means for the heat to get heated up the water, the sludge particles are separated up. The sludge they are separated up so that the heat will have more exposure to the sludge particles, so that water will get easily heated up and leaving only dry particles. So that is the advantage of fluidized bed furnace. Only difficulty is maintaining the sludge in the fluidized condition. Conditioning. It is a process where sludge solids are treated with chemicals or various other means to prepare the sludge for dewatering purposes. What type of chemicals we are going to use? So chemical conditioning is one such a process where we are going to use some of the chemicals. It can be inorganic or mineral coagulants such as iron or aluminum, or organic coagulants or flocculants such as polymers. What does these do? Mineral coagulants such as ferric or aluminum chloride or sulfate, ferric chlorosulfate, polyaluminum or polyferric salts, or quicklime, they are going to used in the mineral coagulant or inorganic coagulants. So what they are doing, they work by reducing the repulsive sludge particles surface charge. Surface charge is now reduced by adding these chemicals. So thereby the activeness is separated out, allowing them to agglomerate through the destabilization effect. Polymers, organic polymers we are going to use, they act by forming bridges between the sludge particles with an additional particle destabilization action. The coagulant or polymer dose required to condition the sludge depends on both the sludge characteristics and the dewatering technology being applied downstream of condition. So conditioning is only a preliminary approach before the sludge is sent through subsequent stages like flash drying or incineration or some other things. So these are some of the sludge handling options which are regularly used in the conventional practice. Out of all these things, for major treatment systems, we are going to use a anaerobic digester or sludge drying beds. Other things, they are used at industrial level for specific purposes of operation and requirements, right? So this is all about the different options available under sludge handling. Okay, thank you.